Welcome to part 6 of this Sylenth Masterclass video tutorial. In this part of the tutorial class, we are going to be looking at the LFO section in Sylenth. And Sylenth's LFO parameters and options are quite deep. It's probably one of the more intricate layers of the synth, including the modulation envelopes. So first, I wanted to go over, for those of you who don't know exactly what an LFO is. An LFO stands for Low Frequency Oscillator. So basically, what an LFO is doing is it's sending an electronic signal, which is usually pulsing via a waveform shape, under 20 hertz, which is the cutoff for human hearing. So you essentially are adding a level of sound to your sound in a synth, but we can't hear it. We can only perceive it as a change in the signal, basically. There's a really cool video you can check to kind of, if you're a visual learner. These guys posted a YouTube or Vimeo video or something, and just go to YouTube and search for LFO water hose. And you'll see that they ran water through the parts of some speakers and actually sent in a LFO, low frequency oscillating wave. And if they got it just right, it would actually make the water bend to the shape of the waveform when they captured it on slow motion camera. So you can see visually that it's actually, that waveform becomes very present in your sound. So when you think of the most prominent and recent use of LFOs, dubstep comes to mind. Skrillex, Brostep, all that stuff. They basically make a gnarly bass sound and they apply an LFO to it, which then does the wah 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 wah, all that stuff. So that's what we're going to be looking at today. And Sylenth has 10 waveforms that you can choose in your LFO section. You have a sine, you have a saw wave, you have a ramp wave, which is kind of like an upside down mirrored version of a saw wave. You have a triangle wave, a pulse wave, an H pulse, a Q pulse, a triangle saw, which is a blend between triangle and saw, a Lorenz, and a sample hold random, and then that's the last one. So you have 10. Now there's some normal ones in here, like the sine wave is a very classic one for an LFO shape. Sine, saw, triangle. Ramp's an interesting one because that's one of the waveforms you don't get for the actual synthesis types in Sylenth. So that's an interesting one. It can go do some cool sounds that kind of, like the name suggests, they ramp up in velocity and intensity. And we'll go through what each one kind of sounds like. I did want to talk about this Lorenz one because it's really interesting. Best that I can decipher, Lorenz, this is coming from this is kind of like a quote chaotic type of an LFO. It's coming from the Lorenz, some Lorenz theory, the Lorenz system, which is dealing with the chaos theory in physics. And then you have the sample hold, which is a pretty common type of LFO where it kind of will make a pulsing sweep to the sound and then hold it at different points depending on your settings and all that. So let's actually start jumping into the idea of, you have all these LFOs, but if you just turn on this LFO and crank up the gain, it doesn't do anything to the sound. You have to basically apply this LFO, this low frequency oscillator, to one of these parameters. And these are the same parameters that you're going to hear that we went through in the modulation envelopes. This box is pretty much the exact same. So you have all these options, and depending on, there's so many variables with what you can do with the low frequency oscillators in Sylenth, because depending on what wave you load up and depending on where you route it to, you're going to get vastly different types of oscillations. And we're going to look at those in this tutorial. First, let's look at some common things that you do with an LFO. So one of the most common places to route an LFO would be the cutoff frequency. So here's this sound that we looked at in the last tutorial. So that's an LFO, basically, and that's kind of the cutoff is how a lot of the dubstep sounds are made. They run an LFO into the cutoff. Another common thing that you'll do is pan for pads and things like that, which we'll get into. You can really get some interesting results using the pan LFOs, like sending an LFO to the pan, because then you start to get a sweep back and forth in the stereo. So let's discuss these options. So we already went over, you have this box with the waveform. You have this little free switch. If the free switch is engaged, the LFO is going to run freely. So what I mean by that is this will change what values appear when you're turning the rate knob. So right now, the rate, if you see right up here, right now it's musical time values, 1 over, so that's an 8th note, a 16th dotted note, an 8th triplet, and so forth, a 16th note. If you click this free, you'll see it just says on now, and I move this, it's now in hertz. So there's a place for both. If you're doing more of ambient sounds that don't need to be tempo synced and tempo locked, you can just use the rate knob to get kind of more of a subtle result. But if you want to have that dubstep feel and you need it tempo synced to your song, then you're going to uncheck free and roll with these actual musical time values. So the note values. Then you have this gain. That's going to turn up the intensity and the volume of the low frequency oscillator to wherever you route it. So this knob basically dictates how much of the LFO effect you are hearing. Then you have this third knob, the offset knob, which can be used to add basically a positive or negative constant value to the output of the LFO. So the value is between -10 and 10. So it's kind of like offsetting the almost the phase of the waveform a little bit, but in more of in a sense of an LFO world. So you can create all types of effects with these LFOs: vibratos, sweeping sounds, spatial effects, the classic dubstep sounds. And going back to the idea of vibrato, I wanted to touch on that. Sylenth doesn't have a dedicated vibrato control. So the easiest way to do it, if you want to do it inside of Sylenth, is to use the LFOs. Or you could use a third-party plugin if you're using Sylenth, like Sugar Bytes Effectrix, and you can do some vibrato type effects. That way, you don't have to go into each synth and make sure your vibrato is matching if you're layering sounds, because Sylenth doesn't have a straight-up vibrato control like a lot of synths do. All right, so this first destination you get is volume. Now, I'm going to turn this I'm going to turn this knob up to about 10 so we can really hear what it's doing. And I'm going to turn the gain up to 10. So it's sending a low frequency oscillator in the turn to sine, so a sine wave. And you can hear it moving like a sine. See how it goes up, down, then up. And the volume is affecting the oscillator for the oscillators for part A. That's why I soloed it. Then you have the volume for B. So if you have any sounds on B, you can just oscillate those. And now this is kind of a fun thing that you can do with the volumes, is you can set volume A and volume B, and then have the rate about, we'll set this on free so it's less noticeable. Turn it down, and then we'll play this. And you can see what's going on if you look at my actual sound here. I'm going to turn it down. Look at the fader. See how it's kind of peaking on the left, then the right, then the left, then the right? Well, it's because you have these different volume levels going for the different oscillators. So then you can do the same thing with pans, and you can start to get some really cool effects. So basically, the sky's the limit with these LFOs. So let's go to the pitch. Now, the pitch is what you would use to do the vibrato. So I'm going to turn this to a waveform. Let's do sample hold. Well, actually, let's do because I want it on the beginning. Let's do a Q pulse for this. So right now, with it's slow. Let's turn back to sine. it's just a crazy kind of sound that's bumping up the pitch. Well, so if I take this down to 0 and take this back down, if I just play one note right now, see how you kind of have that vibrato effect now. So you'd use the pitch. You'd use either pitch A, pitch B, or pitch A and B. Typically, I use pitch B, so the whole sound is affected by the vibrato effect. So this is a multi-part oscillator. So this sound's using all 4 oscillators. So it'd be better to have it on the pitch A and B. And really, what you do for those controls is you just find a rate that you like. Usually about 1/8 to 1/16 works, unless you want a really, really fast one. Turn the gain around 3 to 4, and then just bump your rate up by about 0.19, and you're going to get a pretty good vibrato effect, and it will change depending on the waveform you load up. And taking it a step further, so these modulation envelopes and LFOs work hand in hand very, very well. So right now, the vibrato's a little... it's all right. But what you can do, if I turn up this rate here so it's a little quicker. And then I go to my modulation envelope. Let's take the pitch off of this sound right now. And let's go to LFO gain. And let's turn this up a little. And now let's add some attack. So now we have ADSR, the attack, the decay, the sustain, the release, modulating the LFO. So now I'm not going to hear as much of the vibrato effect I just created using the pitch AB destination in my LFO 1 slot, because I'm now modulating the gain of the LFO via the attack. So you can create cool sounds where we can turn this rate up. See how there's not as much of it when I play a note? And then it comes in as it plays. So you can create those types of sounds where you kind of have where it's just a straight note. Like when you first play it and you're holding it out. And then the vibrato comes in a little bit later. So you have all these options. You can actually modulate the rate too, which is really, really cool. So you have pretty good control over the LFO. It's just different than some synths, because some synths give you that control inside the LFO. It gives you the attack and the decay and the sustain. But that's one way that you can set those parameters and destinations up inside of Sylenth. So now let's move down to this phase. So the phase is going to modulate the phase now in oscillators A1 and A2. So that's just kind of adding some, it almost seems like a pitch variance to me. It's one that I typically do not use a whole lot in the LFO section, because it's not a super noticeable effect, but then if you push the amount and the gain up too much, it almost seems like it's detracting from a sound sometimes. Next, you get the pans, and I'm going to discuss some cool options you can do with the pans. So let's turn this up. So that's pan A, and now let's do pan A and B for LFO2, and we're going to do the same rate. We're going to do a half, so a half note, And the gain I'm going to turn up to about 5. I'm going to turn this down to about 5. And we're going to select a different wave for this. So now let's turn this down to about 2, as well as this one. Now you can kind of hear that sound going back and forth between the pans, which is really, really cool. And now you can spread it out the opposite way to really, really spread it out. And that's something that you can do just to make the sound less digital. So in analog synthesis with actual circuits and wires and air moving through a circuit board, you get some variances when you necessarily don't want them or are not trying to create them in the signal flow. So you can kind of create that effect by using these pans and some of these LFOs to kind of change the pitch, change the drive, change the cutoff just slightly, just to make the sound not as sterile and digital, because sometimes the digital world's great having the ease of these synths on the computer, but sometimes it's just not warm enough in the context of a mix. So now I'm going to go to the filters. So I'm going to zero these out and reset the gain back and set the rate back to the middle. And now in the filters, you have cutoff A, cutoff B, and cutoff AB. So cutoff A is going to affect the cutoff of filter A or whatever's routed into that. Cutoff B is going to affect whatever's routed into filter B. And then cutoff AB will do, basically it's like the master control for Sylenth. So this is what you would typically use if you had like a really beefy bass and you wanted to make that dubstep sound, because you can hear what it does to the sound. So you can see that on that Lorenz wave, it's kind of random. Which is, I guess, why it's tied to the chaos theory. It's not doing something consistently as its counterparts like the Q pulse, H pulse, or sine, or saw. Then you have the resonance, and the reso is going to be affecting either the resonance for filters A or B or both. So this is a cool one. Almost sounds like a tremolo type effect. So that's another useful destination, just to kind of thicken your sound up and make things a little bit more interesting. All right, now let's go down to this miscellaneous section. So if you remember this first slot for the miscellaneous, the phaser frequency, we actually have to have the phaser on. So right now we're actually sending an LFO to the phaser frequency once you have the effect turned on. So I'm going to turn up the rate so you can really hear what it's doing. So that's a really, really interesting one on basses, actually. You can get some crazy sounds with that. And then if you actually set up your parameters inside of the phasing effect, the phaser effect, you can actually get some really, really cool tones out of it. So let's go to this mix A and B. So now it's gonna oscillate between the mix A and B for parts A and B, which is a cool option to have. This is definitely one of those ones that you can use to really kind of strengthen a sound, make it a little bit thicker, a little bit more interesting. And then you have this this LFO rate, which obviously wouldn't be too applicable because you have this LFO rate here. So that's not going to really do anything to your sound, nor will any of these LFO gains, LFO2 and LFO2 gain, and that's just because you have those options. Now, it would come into play potentially if I had something set up here in LFO2 and I wanted to modulate the gain or rate of it through the LFO1. That's the only time I'd ever really want to use it, but you could achieve similar effects just by properly setting up the second LFO how you wanted it. And then next you have this distortion amount. So let's turn on our distortion. So this one's one of my favorite options actually in all of Sylenth. For lead, it is awesome. And I'm going to pull up a lead so I can actually show you. So let's go back to this. Unmute these. Alright, so I'm going to load it up in LFO2. I'm going to click distortion amount and have my distortion on. So now there's this little low frequency oscillator hitting my distortion, which is just going to make the sound thicker and bigger. So that is one of my favorite ones to just kind of, because it lets you subtly add the distortion, but if you just set the dry wet and the amount to how you want in your distortion module, which we'll be covering in the in a couple videos, the signal is going to be constant, right? Like when you hit a key and hold down a note, it's going to go on. The distortion is going to be there for as long as you play a note, and it's not going to change or have any variance. Well, this lets you introduce some variance, so it makes the distortion actually just kind of a tool to really thicken and strengthen your sound. And in a mix, that's really one of the only things that you have is you have all these leads, basses, sounds. They're sharing frequencies, and you have to find ways to let the ear differentiate between them. And effects and processing are some of the best ways to do that. And if you can do it inside the synth, it's always better. Simpler, keeps your CPU amount down. So I do like using this random waveform. It looks like the noise waveform kind of with the LFO distortion. And so that pretty much sums up all the options that you have. And I'm just going to quickly summarize the bullet points that you should definitely take away from this unless you want to watch it again. But if you're trying to do the dubstep sounds, or you're trying to just have that classic oscillating sound, use cutoff A and B, or cutoff A or cutoff B, depending on how your sound is set up. And then the best waveforms for that would typically be the sine, the saw, the ramp, and the triangle. You'll start to get some really weird results with the sample and hold and this Lorenz wave. The triangle saw is kind of a more mellow one, and the random one is kind of almost like a noise. It's kind of crazy. So that would be, I'll show you what the random one sounds like. It's just doing random movements, so it's not very helpful if you're having that as your main lead or drop sound in the form of a bass or a wobble. The next, if you want to create vibrato in Sylenth, the pitch destination, just do pitch A and B. Turn the rate to whatever you want. The gain doesn't need to be that high. And then you're just going to have the gain a little bit up, and this knob is the most important one. You're not going to boost it a whole lot, otherwise it's going to sound like something like this, which isn't going to be too helpful for vibrato. And then next, if you're doing pads, ambience, lush sounds, you're going to want to mess around with the pans and even the cutoffs, and even load up the LFO2, and maybe load in the mix A and B, or the resonance. All four of those together, you're going to get a really cool ambient sound, especially if you're using different waveform types for both LFO1 and LFO2. And if you want to just warm up a sound, try using the distortion amount. It's a more subtle way to use the distortion inside Sylenth. So that pretty much sums up this part of the masterclass. What we're going to look at in the next video are these two miscellaneous sections, and then after that, the final video will be summing up all the effects inside of Sylenth. So thanks for watching, and I'll see you in the next video.